Hello, good afternoon, everybody, or good morning or good evening, whatever where you are joining. Welcome to the third Thursday Science webinar of this month. I'm Angel Muñiz Pinilla. I'm Science Officer at the European Marine Board, and I have the honor to be the moderator of today's webinar. So, first of all, some housekeeping rules that I would like to remind you. At the bottom of your screen, you can see the Q&A option. This is where you can ask questions to the speaker of today. You can also feel free to indicate your name, organization, and country. And then after the speaker's presentation, we will have a discussion, and then I will ask the speaker, Kelsey, the questions. You can use the chat for technical support, if, for instance, if we drop or if you're going to hear something and so on, because that's only visible to the host, and it's also is for us a tool to broadcast any a message as well in case there is something going on. As you probably heard while joining this webinar, the webinar is being recorded and also is being live streamed to YouTube, and is where it will be remain available in our YouTube channel of the European Marine Board, in case you would like to see it afterwards or send it to any of your colleagues. The title of the webinar today is Potential Impacts of Climate Interventions on Marine Ecosystems. And this is really much linked to the Future Science Brief that we published in November last year on monitoring, reporting, and verification of marine carbon dioxide removal. The speaker today is Dr. Kelsey Roberts, who is a research associate in marine ecology, and she's joining from the US. So I really appreciate that she joined from really early in the morning. So without further ado, I would like to give the floor to her, and I will stop sharing my screen, and you can share your screen and your presentation, Kelsey. Up to you. Thank you very much.
Okay. Let's get this. Okay. Are we good on your end? Okay. Thank you so much for the invite here. I am really excited to share my research with you guys. I'm going to put out a quick word of apology that I am at a hotel for a conference this week. So if there's any background noise, it just is what it is. So I'm very sorry about that. I've tried to minimize it as much as possible, but I'll just go ahead and let you know. Again, thank you so much. So this is from a recent review paper that was published earlier this year, finally, after 3 grueling years of work in reviews of geophysics. And it is the potential impacts of climate intervention on marine ecosystems. I have a dual affiliation. I'm a full-time research associate with the University of Massachusetts at Dartmouth. I'm also a part-time visiting scholar with Cornell. So just wanted to quickly acknowledge my funders real quick. So I like to kind of start out with this slide as kind of the justification for I'm sure we've all seen this. And it's a really good paper to read if you want to get your blood pressure up. So this was an update to the 2008 paper that came out identifying the climate tipping points all over the world. And we went from, I think, 8 climate tipping points to now 16 climate tipping points, which is great. And I really kind of like this slide to introduce because it really kind of hammers home what the stakes are here, and especially those that we see in kind of the peach color, which are less than 2 degrees Celsius for the threshold for that tipping points. And as we all know, I don't need to tell anyone on this call, is that we are really not on track to keep our climate under 2 degrees Celsius. We're not meeting our Paris Agreement. Currently. So what is climate intervention? So this is a very broad umbrella term. Sometimes also referred to as geoengineering, although the community has started to kind of navigate away from that terminology, as it invokes a very negative emotional reaction, I think, in people. So not that climate intervention evokes a positive reaction, but this kind of encompasses everything that I'm going to talk about in this talk. And then we have subcategories that kind of branch off from here. So the first subcategory that I'm going to kind of introduce you to, this might be elementary for some people on the call, so my apologies if this is too much background information, but our paper is kind of split into these 2 tracks, one of which is solar radiation modification. So that very broad term, basically encompasses the development of tools and technology for us to turn the sun down. And this is a really great schematic from the National Academy's report that came out in 2021 that illustrates these different techniques and methods that fall under the broad umbrella category of solar radiation modification. So the first one is probably the most well studied. It's been around for decades. It's stratospheric aerosol injection, which is we're dispersing liquid particles or some kind of aerosols into the upper stratosphere that are going to disperse, reflect sunlight, and lower our global temperatures. And we have a very good natural analog for this particular intervention, which is volcanic eruptions. This is exactly what happens when large volcanoes go off. So after the eruption of Mount Pinatubo, which resulted in a global cooling event of approximately 0.5 degrees, you can actually see it in the temperature record. And these two photos really show those aerosol boundaries. After 2 months after the eruption, you can really see these distinct lines at Earth's horizon from orbit. So the technology would aim to mimic what happens naturally using sulfate or something natural. Again, it's, in practice, who knows? We don't have any field trials or anything that has been scaled up to appropriately see what happens to our biosphere under large-scale stratospheric aerosol injection. The second one that's also on the schematic is marine cloud brightening, which is a little bit more of a regional localized type of technology and increasing the reflectivity of low-lying clouds over certain parts of the ocean. And the analog for this would be like ship tracks that create the big plume, and you see actually the clouds that are brightened up, and you have the ocean has a little bit of shade for a little bit until those clouds disperse. There's also cirrus cloud thinning, which is represented on this schematic. I've chosen to kind of not acknowledge that. We didn't look at that for my review paper, and it's just a much less well-studied technique. And there's some questions as to how tractable it is compared to these other two intervention types. So a little bit more on SAI, just so we're aware. There's currently no proven scaled up technology that can make SAI a reality. We don't have planes that can go up to the stratosphere that can continuously inject particles to actually make any type of dent in the global cooling record. The regional effects are kind of, I like to say, the real battleground here. We don't really know what's going to happen on a global scale, and we know a lot less on what's going to happen at a regional scale. And our model configurations are getting better, but they're not quite there yet. And a really important point to mention about stratospheric aerosol injection is there is a very large concern about something called termination shock, which is if you're doing SAI for prolonged periods of time, if you have a good amount of aerosols that are already in the stratosphere that have actually produced some global cooling event that we can see on record, if deployment is stopped for whatever reason, whether that's political, we no longer have the resources, whatever, there is a very big problem called termination shock, which is that temperature is going to rebound very, very quickly, basically potentially back to the point that it started or even beyond the point that it started. And obviously we don't have, our ecosystems and our societies are not going to be able to adapt to that. So a little bit more on MCB. MCB is, you cannot do MCB everywhere across the globe. It's exclusively relevant to certain types of regions with low-lying persistent cloud decks or marine stratocumulus clouds. So this kind of translates to off of California, off of Peru, off of some parts of Africa. You can't do MCB everywhere. It's just not possible. MCB was initially, and there's actually some small scale field trials that are happening in Australia to potentially shade the Great Barrier Reef, which, as we all know, has seen a lot of bleaching events over the last couple decades. I know they've gotten significantly worse. As it turns out, the Great Barrier Reef is a horrible candidate site for marine cloud brightening. It's really hard to brighten clouds that do not exist. So you have to first make clouds before you can brighten them. So they're trying to work that into a larger part of their climate adaptation program. But if you were interested to look at what is actually going on the ground in terms of MCB, there is some work being done in Australia right now. So the shift, again, similar to volcanic eruptions with SAI, but specifically with MCB, The ship tracks validate the mechanism, not the deployability, and our models are actually not anywhere near as mature as the simulations that are done for SAI. The same as SAI, no existing system can currently do MCV with sustained or known outcomes, or there's nothing that is climactically relevant at this stage. Now, because MCB is a lot more spatially constrained than SAI, which is a global scale intervention, this is much more regional. The impacts are not going to be subtle. And I really think it's important, or at least what we tried to kind of hammer home in the paper, is that this is not it seems like it might be a gentler climate intervention option. I think that's sometimes how it's perceived when people hear it. But if you care about coastal and marine ecosystems, those impacts are going to be very obvious, very quick, and there's just a lot of uncertainty there with marine cloud brightening. And the model simulations, like I said, are not very mature yet for us to understand the true impacts of this. And there's a concern that the technology is actually going to outpace the research with marine cloud brightening. So kind of what's this SRM, some of you may have heard of it, some of you may have not. I'm always very interested to see how many people are actually familiar with the word, let alone also all of the techniques that fall under this umbrella term. But I would say over the last 2 to 3 years, maybe 5 years, there has been just a massive acceleration in like media coverage, funding, private investment, corporations that are kind of entering this space, which is making a lot of researchers very, very nervous as those shifts cut both ways. So there's more engagement, there's more funding, there's more resources, which is great. We can improve our model simulations and we can do further impact assessments that previously maybe were not possible with existing model forcing scenarios. But there's concern that we could have bad actors entering this space. That's obviously always a concern. You could have unilateral deployment, which is where an Elon Musk archetype kind of comes along and just has a go. There's no regulatory framework preventing that from happening. And there's also this really big concern of geographic imbalance. So a lot of the research, I wouldn't say a lot of the impact assessments, but I would say the majority of impact assessments are coming out of the global north. The global south is really not very well represented in these conversations, despite a lot of effort to engage that part of the world, and specifically with the volume and magnitude of impacts that are going to be concentrated in the global south. It's really crucial that you have researchers and policymakers and managers and social scientists, economists engaged in this conversation, specifically from the global south. And there's a very low baseline of awareness of SRM, even among climate, environment, human rights organizations. And while there is just this openness to learn, there's a really strong demand for concrete local relevance, which is not something that the research is capable of providing at this scale. So this is actually a quote from a policymaker when this information was kind of put as part of a broader type of engagement for public awareness. Until I know more about the impacts to my community, I have to oppose it, which is a very rational position, just given the amount of uncertainty that we have surrounding these techniques. But it's important to convey that the policymakers' opposition, government opposition, is not equivalent to prevention. There is, again, no regulatory framework preventing any actor coming into this space from just pursuing this technique, monetizing it, copywriting it, whatever you're thinking of. And there's a very large concern that this is going to be pursued under crisis conditions. So you have those tipping points that were shown on the previous slide. In the research community, those in the know, there is just a large growing concern that we're going to reach a tipping point, and the only option at our disposal, some may perceive that this is it. So we really need more research and we need impact assessments. So I like to kind of say that, this is not a scientific debate. SRM is not a debate as much as people like to debate me when I talk about SRM, and I'm solely in the research space. I'm not, advocating for anything, but this is very much a system clash. So it's a very interesting kind of societal and human interaction type of topic that's really fun to bring up at dinner parties. Um, so different actors across the SRM space either view it as this is a problem. We need more research. We need more models. We just need more people engaged in this space. We need people from all different types of research paths engaged in this space. It's either a moral hazard if you strongly oppose it. It's a financial opportunity if you're a corporation or if you're a .com, investor, whatever, or it's an emergency tool. And the future of SRM is very uncertain right now and a little bit scary because I think what we have kind of realized is that the future of this technology is really going to depend on who moves first, who makes the judgment call, who sets the norms, and crucially, who defines progress. We don't have any type of global agreement as to are we aiming for 2 degrees? Are we aiming for 1.5 degrees of cooling? And that's where this really large concern of unilateral deployment is kind of really coming into play, and it gives me heartburn and keeps me up at night. Um, but switching gears a little bit, because our paper again went these two different tracks, and the separate track is marine carbon dioxide removal, which I know many people on this call are well aware of. You probably know a lot more than me. I'm an ecologist, not a biogeochemist. But I do like to point out to people that this is also a climate intervention. I've gotten into some, I would say, disagreements with a few folks at conferences or various workshops, but this is also climate intervention. It's more palatable than SRM, significantly more palatable than SRM. I think that's just because it's, we have a lot of natural influence here, and it's not this global scale, things going up into the stratosphere that just freaks people out. And it's really important to mention that we have the commercialization of a lot of the techniques are already very well underway. So I like to present this slide because I think it's amusing. It's a NOAA infographic, but it's running out of space with all of these different marine carbon dioxide techniques that are entering the market, that are they're coming online and getting funded and getting research interest. And so we didn't obviously look at all of these for the paper. We picked kind of, I would say, the heavy hitters in this space, which is ocean alkalinity enhancement, biomass sinking, and microalgae cultivation. Those were kind of the main ones that we zeroed in on. We really didn't have we didn't have the time to explore every single possible marine carbon dioxide removal technique. And I like to kind of put up this global carbon budget slide as it really, I think, drives home that while MCDR is scaling up and it's being commercialized, it's still very far away from sequestering climatically relevant amounts of carbon and anything that's going to actually make a dent in our ability to combat climate change. So we're currently very low on the scale of the amount of gigatons of carbon that's currently being removed from the atmosphere. And it's important to mention that the bulk of that is actually coming from like natural. So ecosystems doing what they're supposed to do, trees doing what they're supposed to do, rather than through novel technology. So we've got a ways to go if we're going to meet the Paris Agreement, which I think I'm very firmly in the camp of. I don't think that's going to be possible anymore. Hopefully there's people that are a little bit more optimistic about that on the call. I'm a very pessimistic person just in general, but I won't go into that. I'm going to quickly just walk through this because I know, again, many people on this call are familiar with how kind of marine CDR is categorized, but this is how I know that there's some different verbiage out there as to how different MCDR techniques and what umbrella they fall in. So this is how we categorized it, which I understand is very broadly accepted by the community: biotic methods and abiotic methods. And these are the different techniques that we looked at under each of those categories. So quickly, why the ocean matters in climate intervention research. Again, this probably seems like very duh for the people on this call. This is, the European Marine Board. There's already a lot of engagement and care into, caring about our ocean and the future of our ocean. Um, but it's, the oceans are deriving most of the planet's carbon cycle. And when we're talking about ecological systems and how they're changing, and we all know that we see a lot of changes in the ocean right now, but they're responding to a bunch of different factors. Rate, magnitude, seasonality, regional, physical change. And it's very important to convey that climate intervention, despite talking about marine carbon dioxide removal or SRM, they're going to modify all of those. They're not going to single in on the magnitude or the rate. They're going to touch all of those, not in the same potential capacity, but all of those are going to be impacted. Um, Marine ecosystem impacts are one of the least studied domains currently in the climate intervention literature. And that's a gap that I really tried to close in on with the review paper that was recently published. And climate intervention would happen against about a mounting backdrop of climate damages. There's no pristine baseline anymore. So this is the shifting baseline syndrome that we're all familiar with, which is what are we trying to get back to? How are we defining progress? Like, how are we defining how climate intervention could, potentially mitigate some climate change impacts on marine ecosystems? It's like, well, where is it 2015? Like, where are we trying to get back to? Are we trying to get back to anything at all? And that's a bigger problem that I am equipped to solve. That's a bigger question than I'm equipped to answer. And localized physical changes are going to scale up to basin scale ecosystem structure, food web dynamics, species distributions. The list goes on. So really this kind of gets me into like the motivation of our paper, which was we need structure. If we're going to start talking about trade-offs, if we're going to look at how different systems respond, is that the way that my brain kind of likes to think about this is I want a table. I want some type of structure. We have all of these different physical drivers. We have temperature, pH, salinity, we have radiation, we have circulation, and climate intervention again is going to impact those in varied and uncertain ways. And in different climate intervention approaches could potentially solve problems. I mean, that is why these are currently being explored. That is why there's a lot of investment in this space. Some of these could create new problems. There is an argument there that all of them are going to do both. They're going to solve problems, but they're also going to create new problems. And really important for anyone who studies marine ecosystem impacts is like we can't narrow down on one metric and one narrative because we're broad and we need to capture a lot of different moving pieces at once. So we wanted to come up with a structured comparison. We wanted to illustrate where climate intervention approaches align, diverge, where the knowledge gaps remain, and crucially, how we define research pathways forward. So before I kind of get into the tables that I'm going to present, I want to be clear quickly about kind of what we're mapping. So SRM does not perturb the ocean in just one way. It actually perturbs several core physical drivers potentially simultaneously. And at the highest level, these drivers are temperature, radiation, circulation, and chemistry. Each of these affects marine ecosystems through different pathways, from primary productivity to species distributions, nutrient supply, recruitment. Some effects are regional, some are global, and some are direct potential perturbations, and some are going to emerge through interactions. So the kind of broader point that I want to make here is that ecosystems do not experience cooling as a number. They experience kind of the physical footprint of how that cooling is produced. They track the footprint, not the forcing target. So that was really kind of the thought process going into how we design these tables. So don't worry, I'm not going to walk through every single one of these lines. This is available in the paper if you want to explore more. And the point in kind of doing this was we assumed that, different research groups or different policymakers would care about different things. So we really tried to cover all of the bases. So I just kind of want to zoom in really quickly. So my colleague made this slide, which I think is really great because it really kind of talks through our thought process as to how we went through meticulously how we went through each of these boxes and categorized everything. So just as an example, So both macroalgae cultivation and microalgae fertilization have nutrient impacts in the growth zone and the downstream zone, whereas terrestrial biomass storage is only in the downstream zone. So that's where you see this high versus medium versus low categorization. Another example here is the oxic storage of terrestrial biomass. I know this is like word salad, but it's just, we had to squeeze a lot of words into this table. So oxic biomass storage is expected to have greater potential impacts than anoxic, which is why you see that low versus none categorization, primarily because anoxic sites, just by definition, have lower connectivity with the surface ocean, which is where those impacts would occur. So we went through line by line, and that's how we kind of worked out how we were assigning different importance categorizations, and how we were kind of defining each of these different impacts based on the perturbation that we identified from each of the interventions. So a couple of table highlights: high importance, shocker to no one, microfertilization, nutrient addition, biomass breakdown. I'm not going to read all these too, but these cut against multiple CDR approaches. Macroalgae cultivation shows up consistently across biomass creation, DOM release, transport pathways. We have a few medium important scalings for silicate mineral OAE, but really important to mention here is that synthesizing this entire table and boiling this down to just a singular point that we wanted to convey to managers, policymakers, anyone in the decision space is that what we determined had the broadest and highest risk profile was macroalgae cultivation. Our lowest risk profile, electrochemical OAE, and a very close second to that was anoxic storage of terrestrial biomass. The impacts that we really thought that we wanted to convey as super important, and specifically for the development of future research, zeroing in on nutrient dynamics and biomass decomposition are the processes that matter most. And important to note that carbonate chemistry shifts were the lowest across the board for this particular table. Separate table for SRM. So this is kind of what we're looking at really quickly. Again, I'm not going to go through all of these. I'm not going to bore you guys to death, but high importance here, shocker, would be temperature, radiation, and circulation. When you think about things going into the stratosphere, or us adding things to brighten clouds, those seem like no-brainers. And all of these are different depending on if you have a global scale intervention versus a local scale intervention, like marine cloud brightening. With the model inclusion categorization of this one, it was a little bit harder to kind of assign inclusion categories. We're really good at modeling the forcing for SRM, specifically with SAI. Those model simulations are incredibly mature. They've been around for decades, and they've just gotten so increasingly finer scale resolution and resolving different processes. We're not great yet at modeling the ecological translation. So the forcing, I think, is there. What that means for the actual biology is not quite there. We still have a ways to go. And this is, in my brain, kind of the next logical step in this larger puzzle. And I know that there's a lot of different organizations that are really interested in this question, is what happens if we implement CDR, specifically marine CDR, and SRM together? How is that going to work? We currently have no research. We have no quantitative or even qualitative analyses on interactions of different interventions. And the issue is that the research is currently actually very siloed. So the SRM community and the MCDR community are actually, I'm sure with a few isolated examples, are not really in communication. And in reality, what is likely going to happen is that these interventions are not going to be adopted in isolation. They're going to be adopted simultaneously. There's going to be geographic and temporal overlap, and which is likely going to result in a lot of complex and interactive consequences that we have no way of measuring at the moment. So the kind of the seesaw approach that I think about in my brain when I present this is like, when you think about SAI and OAE, there's potential positive consequences there, obviously some negative consequences, but you have potentially an intervention that's going to lower global temperatures. There's little doubt that if SAI is deployed at scale, that is what is going to happen. It is going to result in global cooling. And, you know, OAE can get a handle on, on the CO2 concentrations while SAI is getting deployed up at scale. But we don't have model simulations. We don't have any research on what happens if these two are implemented together. And we have a laundry list of potential consequences and interactions that could happen. And I just listed a couple there. So this is kind of, I think, the next area of research, specifically for myself and for some other people that were on the project. And I'm really interested to see how model simulations can kind of resolve some of these interactions or kind of get at or help us understand these interactions. And I get asked a lot, kind of like it's one of the favorite questions when after my review paper come out and I accepted, some interviews or I talked to some folks at conferences, which was like, do I think that climate intervention is going to happen? And for marine CDR, it's an obvious yes. It's happening. It's getting scaled up. It likely is going to become a very heavy hitter in our battle against climate change. And then you see, headlines like this, which is, Frontier is a gigantic coalition. It includes, I think, Meta, Shopify, Stripe. So there's so many different corporations that are now spending millions of dollars to buy marine CDR credits. Google is also in this space. And what is really concerning is that you're starting to see headlines like this, but for SRM. So coming back to my concerns in this space is that the investment is going to outpace the research. And we are going to get to a point where there's money in this space, there's financial stake in this space, and the research is still very far behind and has a lot of unanswered questions when the policymakers then go to say, give the the go or no go on actually adding this into a portfolio of climate solutions. And then you see, all of these other headlines that are, equally scary and awful. And it's just kind of, it reverberates in the SRM community as well as the broader climate intervention community as a whole, is that it very much feels like the train has left the station, so to speak. And I think I use this as kind of like a call to action for my fellow ecologists and marine ecologists that there are not many of me in this climate intervention space, and I have a lot of research questions. I have a lot of questions that I want answered, a lot of research goals, and I need help. So if you are looking for a PhD project, come talk to me, because our review paper identified so many potential research directions and questions. And now that the funding stream is kicking up, there's just a lot of opportunity in this space. So I will conclude with a couple of key takeaways that I think really summarize what I want you to take away from this presentation, which is that these two intervention types, SRM and marine CDR, will modify ocean ecosystems. Whether that intentionally or not is irrelevant. There are going to be some changes and there's going to be some consequences. Marine ecosystem impacts are not a side issue. They're very much part of the core climate response and need to be studied as such and need to be prioritized as such. And our framework was the first step. There's still a lot of work to go, but we identified which perturbations, which mechanisms, and which uncertainties matter most in this context. So for looking at future research pathways, for example, you could potentially take a hotspot approach, which is you could look at these different rows and identify where the table flags as high importance and low or poor model representation for research projects and research programs. And I put a link to the paper. And with that, I will conclude. And thank you all so much for your attention. I really appreciate it. Happy to take any questions.
Thank you very much. Thank you very much. It's been really interesting. And yeah, I definitely have several questions. So while the participants can also put their questions on the Q&A, and also my colleague can also put in our internal chat. Maybe I have a question for SRM, so solar radiation modification. You said that since for 2 to 5 years has been like an increased interest, investment, and so on. do you know what was the trigger? Because, for instance, from what I understand, marine CDR, because it was, well, CDR was included in the IPCC 1.5 report as one of the options and so on. But I don't
Yep.
know for SRM where it came from, because I've been indeed seeing more and more of
Yeah.
scientific advice and so on this. So do you know where this come from?
I don't know if I can pinpoint it. I think it definitely the change of administration here in the U.S. Certainly contributed. I think I would say this current administration is not friendly to climate change investment and to clean energy investment. So I think it set us back here, at least in the U.S., by many years for our transition to clean energy, and just kind of this recognition that oh, we're we're not going to keep temperatures below 1.5. We're not even going to keep temperatures below 2. I think there's just been an influx of papers over the last few years that there's the even within, for me, for the last few, I've been in this space for 5 years now. When I look back at the conference that I initially attended when I first got into this research versus the conference that I attended earlier this year, and the startups that were there, the government representatives that were there, there were a couple people who ran finance portfolios that were there. So it's just, I think it's gaining traction in a lot of different spaces, which I think is it's small like hits in different spaces that are adding up into kind of this larger push. Um, and whether or not what the specific trigger is, I think for me personally, I would put a lot of weight on the fact that we did have an administration change here in the US. And I think it's kind of been broadly, I don't want to say accepted or understood, but broadly speculated that if anyone is going to make a move in this space, it's going to be either the US or China.
Mhm. Yeah.
And I think it's just it, this is the space that we're in now, and I think it's the enthusiasm, I think, is a lot of concern for me. So I think many people look at this, they see kind of the graphs, they see the plots, they see temperatures being lowered, they see potential for crops to have less of a problem in the future. Their growing season, there's a lot of research out there that suggests that you actually will have crop failure in the future, and SRM could potentially mitigate that. They're seeing this like, oh, we have a solution.
Yeah.
And that's a very, very scary prospect.
Yeah.
But I
And
digress.
And related to that question is also, we have a question from an anonymous attendee, that do you have any examples for frontiers like buying marine CDRs in the, so marine CDR
Yeah.
credits in the SRM sphere, or what, just a comment on things that will happen?
Yeah. With SRM specifically, or moving forward with MCDR?
Um, so I think it was in the SRM sphere.
Okay.
Yeah, if I understand the question correctly. Because I
Yeah.
know that, yeah, put a lot of examples of marine CDR credits. So yeah, please go ahead.
Yeah, so there have been some concerning headlines. I think the one that specifically gave me heartburn recently, and I mean recently within the last 3 to 4 months, is that there is an Israeli startup that is now coming into this space. There's a few existing startups, but they're not very well monetized. This one is. This one is also developing an aerosol or a particle, I don't remember what they called it, to actually deploy into the stratosphere within the next, I think they said 5 years. And when asked what the chemical makeup of that aerosol is, their response was proprietary, which was kind of heart-stopping for a moment. Because this is unfortunate. That's perfectly legal. Like there's no law or rule that says that this needs to be, there needs to be consensus here, that there needs to be there needs to be an oversight board. Like there's nothing. And they were asked point blank, what are you putting into the stratosphere that's going to potentially impact global temperatures? Proprietary.
Mhm.
Terrifying. So
Yeah. there's also, at least for from what I understand, it's also for marine CDR. There's already some regulation going on, or at least some international agreements that at least limits a little bit the go ahead of deployments. But I don't know with I know there's kind of like a space international agreement and so on. So I don't know if you are aware of any kind of like legal.
No,
Yeah.
no. There's a few, the regulatory frameworks are coming in at the individual country or
Okay.
jurisdiction level. So I think Australia was the first to actually put it in writing that no one can deploy anything that falls under the umbrella of SRM without permission, like, or there will be serious repercussions for that. I think some other countries have followed suit, but that doesn't really mean anything when I mean, that's really relevant for MCB as that is a localized regional experiment, although that could theoretically happen outside of jurisdictional boundaries. But you can't, it's really hard when, these people were forced to answer the question, like, how is this relevant to a global scale intervention? It's not, it's an individual, like this is not it's not going to do anything. It's not going to have any, it's not going to hold up in court, basically, is what we resulted in. So no, there's, yeah, as obviously many people are aware on this call, there is a lot of movement to get monitoring, reporting, verification, regulatory frameworks in place for MCDR. The SRM community is very far behind.
Yeah.
Very far.
Yeah. Hopefully they will catch up really soon.
You
And
hope.
yeah. And there are questions from my colleagues because unfortunately they are not able to put in the Q&A, but they put it in the chat, and they are
Okay.
more or less similar. And it's related to one of your conclusions regarding the macroalgae cultivation.
Yeah.
So you mentioned that there is a high risk profile for macroalgae cultivation, but maybe can you explain a little bit like why or what does it mean? Yeah,
So
basically
so
more. Yeah, indeed.
so for this, we just, and again, so I've had some people specifically that are involved in these various interventions specifically, or into these different techniques. And we did the best that we could with this categorization in terms of trying to reach out to different, just trying to do a broad literature search, because these are expert judgment. We don't have a lot of quantitative research to go off of for these assignments. So that kind of statement there is exclusively based on how many high versus medium categorizations we see here. So it's a broader risk profile, I think, is how we frame it for like the policy manager space, because managers and policymakers speak risk very well. I think for the science community, it's a little bit I can reframe it a little bit differently, where there's just more uncertainty in this space, and a lot of uncertainty that needs to be constrained for macroalgae cultivation. And we identified more medium and high importance categories for macroalgae cultivation than the other types of MCDR technology techniques that we explored. So that was kind of our judgment call there. Again, that's essentially what it is. It is a judgment call. I don't have any numbers. I don't have any like quantitative assessments to back up that judgment call. So yeah, I think I could have framed that a little bit differently, as like the last few presentations that were made to policy managers' decision space that speaks risk really, really well. But I think with macroalgae cultivation, I think there's just a lot of uncertainty that needs to be constrained relative to these other intervention types. I don't know
Yeah.
if that answers the question, but
Yeah.
that's kind of what that was my train of thought there.
Yeah, and it's also an opportunity for getting more funding and more research on that area to
Yes,
really solve those
yes,
and reduce the
yes.
risk. And yeah,
Yeah.
um, and then it's also, well, I have received another question here. What does terrestrial biomass storage means in reality? For instance, taking grass clippings to the deep sea. So from what I understand, it's like you grow crops and then you transport it to the sea and then you let it sink, but maybe
Think
you can
it.
explain it better. Yeah.
Yeah. So we actually, I think, so my colleague Morgan Raven is very involved in the biomass sinking space. She's actually kind of a guru when it comes to explaining this. So I'm gonna do an okay job. But I think if you really want more information on biomass sinking, Morgan Raven would be the contact for that one. She's brilliant. But I think we didn't really break it down into. We provided a few examples of what types of biomass are currently being explored. And it's really hard because you have different parts of the world that are exploring different types of biomass depending on where they have the capacity to actually sink it and how long you have. Like, there's a lot of research going on as to how long the particular biomass can stay put before it just re-releases, and you have, all of that carbon just comes back out. So that I think we really honed in on not exactly the type of biomass, but the type of storage, which I understand is really high relevancy right now. Is that obviously there's a numerous different types of biomass. There's kelp. Um, you can grow crops or plants and then, barrel it, wrap it up to where it doesn't actually break apart really easily. But the storage is really key here, is that where you're putting the biomass. You're putting it somewhere in theory. You're sinking it, you're burying it. So the categorization here was more focused on the storage mechanisms rather than the types of biomass that are used. We did provide a few examples as to how that would work, but yeah, that was kind of the track line here. And obviously, as you can see here from this table, is that anoxic storage is a much better option than oxic storage. And there's a few examples of potentially which environments across the globe would be really good candidate sites for potential trial for this technique.
And it's actually just a question came up. Yeah, any thoughts about the idea of biomass sinking in the Baltic Sea? So it's also, as you said, that's I don't know if it will be one of the candidates regions. Because
Yes.
from what I understand, it's quite anoxic, and yeah.
I understand that is a really good candidate site. I understand that there is some really good potential there for slow, virtually no degradation of the biomass material that's being stored there. I am not aware of any actual. I think the results are all theoretical at this point. I don't know if anyone has actually tried it. Or if there's anything that suggests approximately how long the carbon would stay put for before it's re-released. But I do understand that is a very strong candidate site for those that are working on this particular type of MCDR. There's also a few storage sites, I think, in the Gulf of Mexico that are being explored right now. And I think there's a few other really strong candidates. But yes, the Baltic Sea is frequently mentioned as a very good candidate site for biomass sinking. But again, it's hard to say because this one, as I understand, I would need Morgan to kind of drive this point home. But as I understand, is that you'd have to sink a lot of biomass. You would have to sink a lot of biomass for us to get the gigatons of carbon necessary to actually start to see some kind of result. So my understanding with biomass sinking, and again, I'm going to qualify this as maybe potentially a limited understanding, and the field evolves so rapidly. So I say this now, and then in 6 months, it might be a completely different story. But my understanding is this is a type of marine carbon dioxide removal that is supposed to be used in concert with other mechanisms. I don't think it's being explored as a sole solution. I think it's part of all of these are technically part of a portfolio of potential climate solutions. But my understanding with that one in particular is that you really have to sink a lot of biomass. And same with ecosystem restoration is that you can, restore mangroves and salt marshes, but whether or not it's going to be climatically relevant at the scale that we need is a huge question mark. And I think you could make that argument with a few of these, but specifically with biomass storage.
Yeah. And also linking to our document, of course, you have to also put everything into a mixer, because then it's also the cost of transportation, change of land and so on. So you really need life cycle assessment to really assess like if it's really worth it
Yeah.
to do this. So yeah.
Yeah.
Um,
You have to have boats to get the stuff out there, and are you breaking even? Are you?
yeah.
Yeah.
And maybe a question to from Larissa Lorenzi. It's also looking more up north. I don't know if in your research, do you have any link to polar areas? Because sometimes it's less observed, and maybe there's less data there. So I don't know if, for instance, if you
Oh
remember
yeah.
something that's yeah, something remarkable that SRM or MCDR really have an impact there.
I understand that there's a few candidate sites around the Antarctic that are being explored for OAE, I believe, if I have that correct. With SRM, there is actually the current exploration is looking to see if you could inject exclusively at the poles. And the concern there is loss of the ice sheets, which is a very large tipping point and something that we're closing in on, I think, faster than a lot of people want to admit. And again, this is another thing that keeps me up at night. But there are, I think that is the next round of model simulations is exploring how much cooling could we get with exclusive polar. There's a lot of different injection strategies that are being explored for SRM and have been explored and are very well modeled. But my understanding is that how long would we need to inject exclusively at the polar regions to prevent further ice sheet loss? I think is a research objective that you will start to hear more of. It's also, I don't want to say it's less concerning to a lot of people because obviously it's still concerning. You know, the atmosphere has teleconnection, so you don't just inject in the poles and it doesn't just stay there. It's going to disperse. But there's potentially a lower risk profile for exclusive polar injections than injecting at multiple different latitudes across the globe. Um, so I would say very soon you will start to hear potential results coming in from those model simulations. And I know that there's a lot of policy management people in the space that are very interested in that question. Um, as the having ice sheets go away is not something that anybody wants. So,
Yep. Yep.
but yeah. And we
Thank
don't have a
you.
lot of information on what would happen to marine ecosystems in the
Yeah.
polar regions.
Yep. Thank you very much. It's also I'm looking forward to see when this kind of research will come up and so on. It's also staying also in SRM. There is a question from anonymous attendee saying, of course, thank you for your talk. And then when you mentioned MCV, you said that
Mhm.
ship tracks validate mechanism, not deployability.
Mhm.
So can you explain a little bit more? And then they mentioned that there are startups trying to circumvent the IMO 2020 sulfur emissions through MCB proposals from ship tracks. So I don't know if you have anything to say about it or you know.
I think with MCB and there was a regulation that was put in place recently. I don't know if this was a US based exclusive regulation. I would need my colleague Michael Diamond to elaborate more on that. But we actually it really showed how the ship tracks and shading when you put that regulation in place and ships can no longer emit the same um, I don't know. I just call it smog, but I know that there's a technical terminology there. But they tightened down on that, and you can actually see regionally um, temperature changes based on that regulation. So it's very clear actually in the literature how this would work technically, the mechanism how it would work. Um, but again, it's I think my point there was that MCB is only relevant for certain areas of the globe. It's not relevant for everywhere. If the clouds don't exist, then it's really hard to brighten them. So you have to first make the clouds and then brighten them. And we also just don't have a lot of the model simulations that exist for MCB thus far are not what I don't think anybody in the community would call a realistic deployability scenario. It's more proof of concept rather than anything that's policy relevant. And I know that there's a large group of people that are currently working on recent MCB simulations that are more in the realm of policy relevant. I don't currently have access to those, so I can't model what happens to marine ecosystems when we have different deployability scenarios. But yeah, I think that I think my colleague Michael Diamond actually wrote that paper where you actually see the difference after that regulation went in place on large container ships that are coming across the ocean and what happens to the temperature when they're no longer able to emit at the same frequency or at the same with the same chemical makeup, I guess. I don't know. There's a technical term there, but you see these big plumes coming out of ships, and now the regulations are in place, and you don't see those anymore, and no more shading.
Mm-hmm. Yep. And I mean, we are running out of time, and maybe this question is was from a colleague, but it's also I'm interested to know, because you said that you have been working on this for a couple of years, and you see the evolution and so on. Have you come across any conspiracy theory about the chemtrail discussion? Because of course SRM is also with the planes and so on. So it's just kind of like the last question. So I don't know if you would like to respond to it, but I don't know if there's any debates on how these two trends of increasing finance and increasing interest goes along with this recurrent
Yeah.
chemtrail conspiracy theories and so on. Yeah.
It's all wrapped up in one, and that's really relevant because I think the public perception of SRM, and it's not even public. I would think that in a lot of research spaces, and a lot of scientific spaces, and a lot of policymaking spaces, that is almost 9 times out of 10 where their brain goes when they hear about SRM. It's almost like it's interconnected with the chemtrails theory, and there is all of these caveats that have to be put as like, no, like it's not the same thing. Like you have a higher, like we're talking about the stratosphere here. We don't currently have planes that can go up into the stratosphere. So you would not see you would not see this chemtrail, but it's really funny how that is. It's almost an immediate connection. So yes, I have had multiple people, specifically at conferences, or different spaces where I've presented this work, and I've occasionally presented it to the general public. And I will get questions about how, oh, so this is chemtrails. Yes, but no. I, I, it's the conspiracy theory is really interesting, and it's been very difficult to navigate.
Yeah.
I will say with in this space, and particularly trying to hammer home that not I am not advocating for anything. I am trying to close the research gap, trying to close the uncertainty gap, trying to produce impact assessments that can potentially be valuable for decision makers. I am not in any way, shape, or form an advocate for any of these technologies being deployed. That is and that seems to help the conversation a little bit, but I get a lot of it invokes a very strong emotional reaction, I will say. And yeah, it's funny that they bring up chemtrails because that is a question that I get a lot. So
Okay, so I mean, you already have thought about it, and then you have a really good response. So I'm glad that people take it.
I have my pitch ready to go.
Okay.
I'm not a decision maker. I'm just a researcher. So
So we are almost at the hour, and I have one last slide to invite the people for
oh yeah.
the next one. But then, thank you very much. Has been really interesting. I learned a lot about the SRM specifically, but also on marine CDR, we see that also is really aligns with what we have written in the Future Science Brief. So I would like to say thank you again, and then
Thank you
we
for the invite.
invite you all. Yeah. And we invite you all for the next webinar, which is going to be next month on the 21st of May. And it's going to be on dark oxygen with Professor Andrew Sweetman. And this is really related to another future science brief that we have on ocean oxygen. So with that, I would like to thank you. Thank you all for participating, for posting your questions. And yeah, hopefully to see you at the next the next month. So, and thank you again, Kelsey, for joining for so early, and thank you for keeping up with us. All right. Have a nice day.